Okay, it's time, and so I'm going to start my today's session. In today's class, I'm going to discuss about matrix inverse. And also I'm going to introduce the system of linear equations and their solution process. Now, to discuss this, I am referring all of you to the page number 162 of the fourth edition of Friedberg. And I'm going to write one result from that particular page, which will be beneficial for us to discuss today's topic. Okay. Now, you know that I told you in the last class, as I can remember, that a square matrix, a square matrix of order n is invertible if and only if the rank of the matrix, a square matrix, let us name it as capital A. Okay, then in that case, the rank of the matrix must be equal to the order of the matrix. So suppose this implies that, very briefly I'm saying, that if I give you a square matrix like this, say for example, okay, suppose this is my square matrix. So initially what we do, what we usually did, we usually try to find out the determinant of this particular matrix, and we can see that determinant of that is 2 minus 2, which is equal to 0. And obviously this implies that A inverse does not exist in this case. And if I want to put the language of rank over here, then I must say that, okay, this square matrix A can be this square matrix A can be written in its equivalent form by applying some elementary row operations over there. Let us, for the time being, let us stick to row operation only. And if I apply row operation, then I can keep the row 1 of the old matrix as same as row 1 of the new matrix. So if you write here old and suppose this is new, they are basically same. But R2 new can be written as R2 minus 2R1. Okay, and therefore we have, if I multiply the first row by 2, then we get 2 and 2 over here, and 2 minus 2, that is 0, and 2 minus 2, that is 0. So you see, you cannot reduce further this matrix. Okay, and therefore rank of this particular matrix is 1, which is less than 2, that is order of the matrix, order of the matrix. And therefore, according to this theorem, which I have stated over here, A inverse does not exist. And I also told you that usually I deal with this particular process of finding matrix inverses if the order of the matrix is more than 3. Okay, and this is actually the general process. Okay, determinant, the concept of determinant actually comes from that. And you have seen that in the book also, the determinant chapter comes after the discussion of the matrix inverse in the section of 3.2. Okay, so actually in determinant, what happens, we deduced the concept from the concept of matrix. But in school, probably you have been taught determinant first and then matrix. I don't know, but yeah. So both of these are actually interlinked to one another. So for now, we shall be using this process to find the matrix inverse. We shall try to figure out whether inverse of the matrix exists or not by calculating the rank of the matrix. So I have selected a problem for you from the exercise, and the problem is, I'm referring page number 166 of the 4th edition of Friedberg. And the exercise which I have chosen to discuss matrix inverse is this one. 1, 2, 1, minus 1, 1, 2, 1, 0, 1. So that is our matrix. So let us name this matrix as capital A. First of all, I shall try to find out the matrix inverse using the usual process. I mean, the way we are familiar with. Okay, so let us try to do it in that way. So if I want to apply it, we must calculate determinant of A. Why am I doing this in usual way? Because since I shall be using a new method to find out the matrix inverse, first of all, it would be nice if I use the old method so that the results can be compared together. Okay, so therefore I have decided to uh, discuss the old method first, the method we are comfortable with, and then we can venture into the new world. So determinant of that can be written as minus 1 to the power 1 plus 1, 1 into 1, 2, 0, 1, plus minus 1 to the power 1 plus 2, 2 into minus 1, 2, 1, 1, plus minus 1 to the power 1 plus 3 into 1, that is minus 1, 1, 1, 0. Okay, and that this term is positive, this term is negative, this term is positive. So this becomes 1 minus 0 multiplied by 1, okay, plus 2 into minus 1 minus 2, and this is 1 into minus 1 into 0, that is 0 minus 1. So we actually get this 1 plus 2 into minus 3 minus 1, and therefore the determinant is minus 6, which is not equal to 0, which implies A inverse exists. Okay, now to find the inverse of the matrix, what we do, we use this particular formula. What is the formula? The formula is A inverse is equal to adjoint A by det A. Okay, what is adjoint A? Adjoint A is which is usually denoted by AdJ of A, is actually the transpose of the cofactor of A. Cofactor of A, its transpose. Okay, cofactor of A is also a matrix, so its transpose is the adjoint of A. So let us try to find out the cofactor of A first, and then we'll take the transpose to find the adjoint of A. Now, so cofactor of A can be written as, okay, and that is, you know, that the first element is minus 1 to the power 1 plus 1, and that would be 1, 2, 0, 1. The second element, just to save the space, let us not write the positive sign and negative sign, because you know how it comes. So first term will be positive, and that would be 1, 2, 0, 1, the second term would be negative, and that would be -1, 2, 1, 1. The third term will be positive, and that would be -1, 1, 1, 0. Then the next one will be negative once again, and that would be, I mean, I'm talking about this particular term. So if I omit this row and that column, it would be 2, 1, 0, 1. Okay. Next one will be positive, and that would be 1, 1, 1, 1. And the third one, the sixth one will be 1, 2, it would be negative. So 1, 2, 1, 0. Okay, it would be 1, 2, 1, 0. Then again positive. So that would be 2, 1, 1, 2. And the next one will be negative. So that would be 1, 1, -1, 2. Okay. And the last one will be positive, and that would be 1, 2, -1, 1. Okay. So that is my matrix of cofactors. So what do we get? What do we get from there? We get, I'm writing here. So we get So we get 1, 1, 1 minus 0, that is 1 minus 0. Let us write it in this way, 1 minus 0. Then we get -1, -2. Then we get 0, -1. After that, we get -2, -0. Then we get 1, -1. Then we get -0, -2. Minus of 0, -2. The last one is, the last row gives you 4, -1. Then we get minus of 2 minus -1 into 1. And the last element would be 1 minus -2. Okay. If I'm not wrong, then that is the matrix. That is the cofactor of A. Cofactor of A. Okay. That is the cofactor of A. Now, I can erase that because this job is done. And your cofactor of A thus becomes, your cofactor of A thus becomes 1 minus 0, that is 1, that is -3. So 1 minus of -3, that is +3. 0 minus 1, that is -1. That would be -2. This is 0. That is minus of -2, that is 2. And the last one is, the last row gives you 3. Then this is actually 2 minus -1, that is 2 plus 1, that is 3, that is -3. And lastly, we get 1 minus -2, that is 3. Okay, so it's called matrix of cofactors. Okay, that job is done. Then adjoint of A becomes, adjoint of A becomes, or let us write it as ADJ of A. It is, if we have to take this matrix into consideration, and we'll take its transpose, and that becomes 1, 3, -1, -2, 0, 2, 3, -3, and 3. So that is my matrix of the matrix given by adjoint of A. Okay. And after that, using the formula, so A inverse becomes adjoint A by det A, and therefore we have to divide each element by, what was the value? -6, I think. Yeah. 1 by -6, -2 by -6, 3 by -6, 3 by -6, 0 by -6, -3 by -6, -1 by -6, 2 by -6, 3 by -6. And therefore, your A inverse becomes -1 by 6, that is 1/3, that is -1/2, that is -1/2, 0, 1 by 2, that is half, 1 by 6, -1/3, -1/2. So that is your A inverse. What was the value of the determinant? I think it is -6 or +6. What was the value? I forgot. What was the value? Can anybody say? Was it 6 or -6? I actually +6. Okay. Fine. No. +6 is the correct answer. +6, yeah, +6. So okay, so that would be, sorry, for that would be, these things will be plus then. So plus, 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 and therefore first one will be the 1 by 6, second one will be -1/3, third one will be half, and this one will be half, second one will be 0, and the last one will be -1/2, and it would be -1 by 6. This would be plus. Okay. This would be plus, and the last one will be plus. Yeah. Now it is all right. 1 by 6 -1/3, half, 0 -1/2, -1 by 6, 1/3, half. Okay. So we have ultimately got this matrix A inverse. Okay. Someone said in the chat box that he has got 5. Who is that? Dheeraj Kumar Singh. Just recheck your calculation. So this is your inverse matrix. Now I'm going to write one result in the next page. The result is taken from page 162, page number 162. And the result goes like this. If capital A is an invertible matrix, capital A is an invertible n by n matrix, and the matrix this is transformed into a matrix of the form by means of a finite number of elementary row operations then, sorry for the interruption, suddenly the network got disconnected. So I lost my whiteboard. So in brief, I'm saying that capital A was n by n matrix. Okay, reference page number 162. This was the n by n matrix, and I want to transform a matrix AIN into a matrix INB by elementary row operations that I wrote in my session before the disconnection. Then capital B is actually known as A inverse. Okay, so that is the theorem which is given in the page number 162. Now here, one important point is that, first of all, probably you are able to identify this matrix of this form. Both of these matrices are actually known as augmented matrix. Both of these matrices are known as augmented matrix, and I can recall that I defined augmented matrix in my previous class. And in the previous class, I told you that you can find the rank of a given matrix by using both row operations and column operations, and by bringing the matrix into its normal form. But here in this particular result, they have written that you can bring this augmented matrix to that augmented matrix by elementary. You are supposed to apply elementary row operations only, not the elementary column operations. Specifically, it is mentioned. Okay, maybe there are some reasons for that. Okay, so you have to find it out by yourself. So, and what is IN? These INs are actually square matrix of order n. So IN is actually the square matrix of order n. Square matrix of order n. So what I'm going to do now is that I'm going to find the inverse of the matrix. I'm going to find the inverse of the matrix which has been found over here just before the disconnection. That matrix I'm going to find using the above rule, using this particular rule. So let's begin finding of inverse using above rule. Okay, so let's start. We had the matrix capital A was 1, 2, 1, minus 1, 1, 2, 1, 0, and 1. And since I have lost my previous white board work, so once I do this particular problem, please tell me in the chat box. Once I enable it, please tell me whether the matrix which I obtained by using the usual method is similar to the matrix obtained in the by the current one. Okay, so you are going to tell this to me. So let's begin. So since this matrix is of order 3 by 3, so I have to select an identity matrix also of order 3 by 3. Okay, and both the matrix will be augmented together. So we shall write AI, okay, that is equal to, write the matrix, original one, first of all, 1 2 1 minus 1 1 2 1 0 1, put a dotted line like this, and beside that you write 1 0 0 0 1 0 0 0 1, and according to the rule, here I'm not going to apply any row operation. I'm only apply I shall only apply sorry, no, I'm not going to apply in column operation. I'm going to apply only row operations as stated over here. Okay, so column operation is prohibited now. Now let us begin to find, and let's see what happens, what comes. So this matrix is equivalent to, what I can do is that I can keep row 1 unchanged, and row 2 can be written as row 2 plus row 1. Okay, and row 3 can be written as row 3 minus row 1. Since I have already done this particular problem, so I'm just seeing what operations I have made over here, and I'll suggest you to do the same before you proceed with operations. First of all, you decide, you plan what you want to do. First of all, you plan what operations you want to play with, and then apply. Okay, after writing, don't write the operations. First write the operations, then apply. And why am I doing these operations in this manner? Because according to the theorem, you are supposed to bring a matrix. This left hand side matrix is your A, and the right hand side matrix is your identity. I want to interchange the position. I will make it identity, and this identity will become something else. Probably the B which I've got, that is A inverse which I've got. So first row will remain same. Okay, and I'm going to change R2, so that would be 0, that is 3, and then that would be 1 1 and 0. Just look at the operation. And last one will be 1 minus 1, that is 0, that is minus 2, that is 1 minus 1 0, minus 1 0 and 1. 9 minutes 51 seconds left for this session. I'm enabling the chat box, so you write your names in the chat box and write quickly the matrix, because I can quickly shift to the next page if this page is actually filled up. Okay, so write your yeah, okay, do it quickly. So that is my first operation. Then I have applied an operation like this. I have applied this operation. I kept everything unchanged. R1 unchanged, R3 unchanged, except R2. And in R2, we have divided the elements by +3. So consequently, we get 1 to 1, 1 0 0, and that would be 0 1 1, 1/3, 1/3, 0 0, -2, 0, -1, 0 1. Okay, so you quickly write, because my page is exhausted and I'm going to shift on to the next page. I'm going to save your chat. Also, I can see the 39 participants have written their names in the chat box, but number of participants present here is 47. So I'm asking others, probably remaining students are actually sleeping by opening the video. So therefore they are not writing anything. So only these 39 participants are going to be marked present. Okay, if others are listening, then you can write in the chat box. Now that counts 40 and 7 students still remaining. Okay. Now, next operation I'm going to make is that my next operation is I have kept R2 unchanged, R3 unchanged, and R1 has been written as R1 plus R3. So by applying that, to your matrix. I'm just copying it from here, from my calculation, because there is no time in fluctuating between pages. So after this operation, I have actually got 1, 2, 1, sorry, 1, 0, 1, 0, 1, 1, 1/3, 1/3, 0, 0, -2, 0, -1, 0, 1. You can check whether you have got this or not. Okay. Now after that, the operations which I've applied is that this is equivalent to, now I have kept everything unchanged except R3. So R1 is unchanged, R2 is unchanged, and in the case of R3, we have divided the elements of R3 by -2. So this becomes 1, 0, 1, 0, 0, 1, 0, 1, 1, 1/3, 1/3, 0, and that becomes 0, 1, 0, and that is half, 0, -half. Okay. And then we have applied an operation where R1 has been kept unchanged, R3 has been kept unchanged, and R2 has been written as R2 minus R3. So we can write first R1 because it is unchanged. Then you can write R3 because it is unchanged. And the elements of R3 will be subtracted from elements of R2 here to make the elements of R2 changed. So we get 0 minus 0, that is 0, 1 minus 1, that is 0, 1 minus 0, that is 1, and 1/3 minus half, that is -1/6, and 1/3 minus 0, that is 1/3, and 0 minus half, that is +half. Okay. Now you can interchange between R2 and R3. You can interchange between R2 and R3, and consequently we get, we'll keep R1 unchanged, and we can interchange between R2 and R3. So we can write it as 0, 1, 0, half, 0, half, and that would be 0, 0, 1, -1/6, 1/3, half. Okay. Now, lastly, we can subtract R3 from R1 to get the following matrix. It is almost, you look at this matrix, it is almost identity. Okay, so to make it identity, we have to make this element 0. So we can keep R2 unchanged, we can keep R3 unchanged, but we can subtract R3 from R1. So thus we get 0, 1, 0, half, 0, half, 0, 0, 1, -1/6, 1/3, half, and that would be 1, 0, 0, 0 minus 1/6, that is +1/6, 0 minus 1/3, that is -1/3, and 1 minus half, that is half. Now you see, we started with this matrix A, and on the right hand side we had I, and now lastly we have got, on the left hand side we have got I, that is I3, and on the right hand side another matrix which is, let us name it as capital B. Now, since you don't have to recheck your calculation, because you can say that whether you have, in usual process, what happens when you apply the matrix inverse formula, and when we divide by determinants, then as you see, as you can recall that I made a mistake by putting -6 in place of +6 because I forgot what values came. Here you can see that there is no provision of making mistakes, because if you are mistaking, then in that case on the left hand side the actual identity matrix will never appear, because both of these two operations made on right hand side and left hand side of this vertical bar are actually interconnected to one another. Any mistake done in the calculation will not bring identity matrix on the left hand side, and that implies that second row sixth element is not matching. Why is not matching? But I can see it is matching. No, you are just check your calculation, it is matching that same matrix I have got in the previous case. Probably you have done a mistake, you just check your calculation. So capital B, and if you have any, and if it was a mistake, then in that case if it was a mistake, then in that case, oh okay, you are saying that one should be probably, no, probably if in this part here I probably here is a mistake, and for we have made a mistake there. You have to check it, because if I subtract R3 from what I want to subtract R1 R3 from R1, and in R3 we had what did we have? Just a minute. 0 0 1 minus 1 by 6 1/3 half. Oh, that is -1 minus half. Okay, I got your point. And 0 0 1 half 0 minus half, that should be minus half, and that is -1 by 6 1/3 half. I think now it is all right. Now it is all right. Some mistake, there must be some mistake. Okay, I since I was copying the, I made this mistake. Okay, sorry. But the main important point is that you have to be very careful and while calculating, because if you make any mistake, left hand side I3 will not come. So in that case, we can say that B is your A inverse. Time is running out. We shall discuss in the next session.